previous example up to see if you can do
Okay.
it correctly.
Would it be -3, -5?
Yes. And these tell you the transformation. So is it up, down, left, right, three?
Left 3.
Okay. And then how about the other one? Down,
Down
left,
5.
right, down five. Good. Okay. You got that down. That's fantastic. Let's look at another one here. All right. Give me the vertex of this, please.
That would be -2, comma 1.
Good. So there are actually three transformations of this problem.
Oh,
Left
okay.
two, up one, and then there's this negative symbol. Do you remember what that does?
It is a vertical reflection, right?
Yeah. So it's a reflection over the x-axis.
Okay. Got it.
All right. Let's see what else. I'm trying to decide here. You got a variety of problems here. They don't really work together. Let's do another one. I'll give you another h of x. Um, minus 3x plus 1 squared plus 4. This has four transformations. Can you tell me any of them?
Well, left 1, up 4. Uh, Reflection over x. And, well, there's the squared. I don't know if that does anything.
Nope. What about this 3 in front? You remember anything about that? What that number
Oh,
does?
yeah, that is a vertical. I know that it's a stretch.
It's a vertical stretch of 3. All right, very good. Okay. So a lot of the things we just did apply to other functions. The one that they most commonly apply to that isn't on your page, but I'll just give you one example of that. Let me go L of x. Doesn't look like you're using that. Let's go, let's say it's minus 1/2 absolute value x plus 4 minus 5. Like the parabola, this has a vertex.
Okay.
So that's also a transformation. This has four transformations again. Can you give me any of them like we did in the last problem?
Yeah. Left 4, down 5.
So the order matters, and like I'm not really emphasizing that. I don't know if they do in your school. I don't think they do, but really the order does matter. Like that's the last one, down five. These next two are interchangeable, but they come from this here.
And then vertical reflection, or reflection over x.
Yeah, vertical reflection is fine, but they usually want you to specify the axis.
And then 1/2 vertical shrink, right?
This is a shrink, yeah, because it's less than 1/2. All right, good. Really good. Okay. The other type of problem you will see is, I guess I gotta use another letter. Let's say you get a of x equals minus square root x plus 2 plus 1. This has three transformations. Can you give me any of those again?
Uh, yeah. Is it still left 2, up 1?
Yes. Yes, left 2 and up 1. What about this negative out in front?
Reflection over x.
Okay, good. Okay, I feel like you definitely have that down. The your instructor gives you a few odd ones here that I guess we'll look at. That at first glance you may not know what to do with. So let me snip a few of these in, and then we'll actually do some of the transformations. All right, so this is the first one here. It's negative inside parentheses as is. You're supposed to then factor it out of both,
Okay.
which means that it's this whatever goes in here when you distribute the negative in has to get you back to this line. So what goes inside parentheses such that when you distribute the negative in, you get back to negative x plus 3?
Just X and 3. What do you mean?
Well, if I put x plus 3, when you distribute the negative in, you get negative x minus 3. Is that the same as this previous line?
No. So
So
negative plus or so minus 3 then.
minus 3, yeah. And essentially, whenever you have a negative on the outside, you're just changing the signs, right?
Okay.
All right. Now this has one, two, three transformations. Right 3, up 1. When the negative is on the inside like this, it has the effect of a reflection over the y-axis.
Okay.
Okay. Now this is kind of going back in the way back machine here. When you first learn to graph the square root of x, do you remember any of the values that you try for x?
Uh.
Like what values can you take the square root of?
All right. Square root of 4. Square root of 9.
Smaller. Give me smaller.
1.
Okay. So this is like your parent function.
Okay.
Okay, so if you read the instructions, it says they want 3 transformed points. So you have to
Okay.
know how each of these affect whether it affects x or y. So does right 3, does that affect x or y?
Um.
Like you
X.
literally go to the right. Yeah, this affects x. Does up 1 affect x or y?
Y.
So those are the same no matter what problem you're looking at. Okay. Now, reflection over the y-axis is a little bit harder to maybe visualize, but imagine you had a point, is it the y-axis here? Yeah, you had a point A, and then you go to A prime. Does that affect the x or the y?
X.
That affects the x, yeah. So the
Okay. Also,
transformed,
sorry if it gets a little loud because the school just ended, so I think people are leaving and stuff.
yeah, you can always mute yourself, and then if I don't hear you talking, I'll just ask or wait.
Okay. I'll mute
Um,
myself for a minute, but I'll be listening.
okay, well, this is where I'm gonna have you jump in at some point, but these
Okay.
x values are affected. So the new x values are right 3. You're adding 3 to each of these x values, and then you're negating them. So 0 plus 3 is 3, but then you negate. You will eventually negate. Um, so how do I want to do this here? Let's do. Um, how do I want to do this? 3. I'm sorry, you negate and then add. Okay. So I gave you the order here wrong. That's the issue. I don't know why I did that, but these actually switch orders. So you actually negate the x first and then add 3. So like, for example, 4 is negated and then you add 3 to get -1. 9 is negated to add 3 to get -6. 16 is negated to add 3 to get -13, like that. So could you put these into the right side here and give me the outputs? And you can type them in the chat if it's inconvenient to speak them. And you can take a
Okay,
minute
I
or
think
two
I'm
if
good.
needed.
There's
Okay.
less people here today than I thought. Um, but okay, so wait, I'm confused though. Where are we getting these right x terms from?
They're coming from the transformations. And so this is not the best example. Don't worry so much about that. We'll do a better one in a previous problem. But um,
Okay, should I just do it then?
yeah, just give me the outputs, please.
Um,
Whenever you got them. No rush. Just take your time.
okay, so for 3, 1,
Okay, good.
um, 2, 2,
Okay.
uh, -1, 5,
Tell me a little bit more about this one. Why is it 5?
-1 -3 is -4, and then since you already have two negatives, they cancel out, and then you add one, and it's 5.
What about the square root here? You got to do that first. Square root of 4 and
Oh,
then add the 1.
whoops. Okay, so square root of 4 is 2, plus 1 is 3.
Okay.
And then not so, and then -6, 4.
You could see the pattern there. All right, good job. Um, yeah, so you, you had a good question here. Let's go to something more traditional here. Do you remember the parent function table for this
Uh,
for x squared? Do you remember what goes on the right?
well, I know how to like square it,
Okay, give me those values.
but were those random x values that you just picked up?
No, no, these are the standard set. Um,
Okay.
it starts at the vertex and then it goes left and then right.
Okay.
But you have to know the parent function. So give me the outputs over here on the right.
Uh, 4. So -2, 4.
Okay,
1,
good.
0. 1, 4.
Very good. Okay. So now let's say I give you a function like this, one we looked at earlier, x minus 4 squared plus 3. What are the transformations of this?
Um, we got right 4, up 3.
Okay, so the right 4 affects the x and the up 3 affects the y.
Okay.
So in terms of our table, all the x values are going right 4. Right 4 means adding 4 to all the x values. Could you add 4 to all the x values here? And tell me what that new
Uh,
list is.
add 4 to all the x values. Okay.
Yes.
Um, so 2,
Okay.
3, 4, 5, 6. Yeah.
Good. All right, good. Now, there are two ways to proceed from here. One is to actually put these back into the equation. I want you to put 2 back into this equation and tell me what the result is. Then we'll talk about the faster way.
Um, 2, 7.
Okay, now that 7, 3 up from 4. Up 3 means to add 3 to the y value. So
Okay.
if you add 3 to all the y values, you get your new transformed set of numbers.
Okay. Hmm.
Any questions, thoughts on that?
No, that's interesting.
Okay. All right. Wow, so a lot of other stuff here. So let's look at a new problem here. Um, all right. Uh, any idea what the vertex is on this one?
Uh, well, I guess I can guess and say maybe -2, -18.
Okay, what if I write it this way? Can you tell me the vertex now?
Yeah. So just be 0 and -18.
Okay. And the good news here is that x minus 0 is x, and that becomes x squared, 2x squared minus 18. You're good. Okay. Uh, now the transformations here. There are actually only two transformations. It's this 2 out in front and this minus 18. Can you give me what the 2 out in front is?
Yeah, vertical stretch of 2.
Vertical stretch. 2. Does that affect the x or the y?
Uh, I thought it was just the slope. Like,
It affects the y. It's like pulling a point up or down.
okay.
All right. The next thing here is the 8 minus 18. What is that transformation?
Um, that would just be 18 down.
It's down 18. All right. Very good. So now if we go back to our standard set here of x, y, -2, -1, 0, 1, 2, 4, 1, 0, 1, 4, down 18 affects the y. So we have to do this in a certain order. So the order is, see how these both affect y, but not x?
Yeah.
X stays the same. But your new y, you're first going to multiply the y by 2 and then subtract 18.
Okay.
So you're going to multiply by 2 and then subtract 18.
Okay. So let's see. -2, -2, -10. Um, -1, -17.
Okay,
0, -18.
good.
-17 again.
And then -10. So the idea here is that if you know the transformations and you know whether they affect X or Y, you don't have to recalculate them. You can just use the table.
Okay.
All right, we're going to transition to a new topic here, average rate of change.
New topic.
Yeah, it's on the bottom of the page there, but it's something that's kind of its own little thing. I'll be right back with you. All right, so you'll see this, they call it average rate of change, and then they shorthand it by saying A rock. Um, It has a formula, f of b minus f of a over b minus a. Okay, and we're gonna work through a few examples together. So let's just say the function is 2x minus 3, and I want the average rate of change from 1 to 5. Okay, so they have to give you a function, and they have to give you what's called an a and a b. All right, so you're responsible for knowing this formula. Like you have to memorize that.
Okay.
And then we use that formula here by putting in the numbers here. F of 5, that's b, minus f of 1, that's a, over 5 minus 1. Take a 30 seconds to look at that. Make sure you understand, where I got those numbers. Then we'll talk about what to actually do next.
Uh, yeah. So the y minus the x, basically.
Well, these are both x's.
Oh, but the second number is just the first number in the equation, basically, right?
Yeah, well, we're gonna calculate f of 5 and f of 1. So the other day we were doing all this function evaluation.
Yeah.
So you've got to put 5 in for x and then 1 in for x.
Okay.
Can you do that for me, please?
Yeah. Uh, so it's just what, f of 4 over 4?
No, 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 no. You're putting five in for x in this function.
Oh shit, I didn't see that. Okay, my bad.
All right, let's
Yeah, sorry.
keep it clean. Um,
Oh yeah, my bad. My bad.
we don't
Sorry,
need
anybody that's
we don't need YouTube coming down on me for harsh
sorry YouTube.
language.
Sorry YouTube. Okay. Um, so f of 5 equals 7.
All right, f of 1. What is the f of 1?
And then, oh yeah, f of 1 is -1.
Good one. Good. So now it's 7 minus minus 1 over 5 minus 1. Can you reduce that for us, please?
Yeah. So that's 8 over 4, which is 2 over 1.
Yeah, good. Okay, so let's do another one here. Let's say f of x is 2 square root of x, and I want the average rate of change from 1 to 9. 1 to 9. So completely new problem, new function.
Okay.
So the formula is f of b minus f of a over b minus a. They're going to give you an a and a b. They have to. Like you're not expected to come up with them on your own. You do have to evaluate the function. So you have to find f of 9 and f of 1.
Okay. Uh, so this, so it's 6 for 9, and then 2.
Okay, so those go back in here. It's 6 minus 2 over 9 minus 1.
Yeah.
Go ahead and simplify that for us, please.
So 4 over 8, which equals 1/2.
That is correct. All right, so I'm going to give you some problems to try. They're going to be more difficult than this, but any questions on what we did so far?
I don't think so.
Okay. All right, so I'm going to pick and choose a little bit from your page here. I want you to find the average rate of change from -1 to 1 for this one, please.
Okay. Okay, so it would be -1, so -1 times -6. So for -1 equals 8.
Okay. I already know how to do this problem, so I'm looking for you to work this out and give me the final answer. I'm happy to scroll up if you need to look at the previous problem.
Yeah.
Um, if you need, or if
Yeah.
you need the notes again, that's fine too, but
Yeah. Can I
yeah,
see
of
that again?
course.
Let me get my paper out so I can. Okay, I'm good.
You got this down, or you need another moment, or do you want to
I'm
keep it on
good.
screen for the okay.
I know what it is. I'll write it down after we do this. So f of -1 equals 8,
Okay.
and then f of 1 equals -4. So let me write that. 8, 1, 4, and then it would be -4 minus
Is that your final answer?
8. Here I'm writing the. It's just b minus a on both, right? Or crap, I thought I.
Gotta have this formula down.
What the heck? Well, I'm doing it right now, and I'm realizing it's the same thing. That's kind of weird. Uh,
So I mean, I didn't put. You can make. I mean, if you want, you can change that to F. That's fine. Um, you have to find f of 1 minus f of -1 over 1 minus -1.
1 minus -1. I thought it'd be -4 minus 8 on the bottom.
If you look back, the a and b values are on the bottom. It's b minus a on the bottom, right minus left. Same thing here, 5 minus 1. It's not the output.
Oh, the output is on the top.
Yes.
Oh, shit. Okay. Oh, shoot. Shoot. Okay. Shoot. Um, so it would be -12 over um, 2.
Okay. So what does that become?
That would be -6.
All right. Good job on that. All right. Let's try another one. All right, so let's call this f of x, average rate of change from 3 to 6. 3 to 6 this time.
Okay. All right. Let's see. So windy. Okay, my paper keeps flying over the place. Okay. Uh, 3 f of 6 -2. 0. Okay, I got -1 is the final answer.
All right, so we got f of 6. That sounds right. F of 6. 6 minus 5 squared minus 4 ends up being -3. Is that what you have?
Yeah.
3 minus 5 squared minus 4 ends up being 0. So this ends up being -3 minus 0 over 6 minus 3, which is -1. All right, let's try a slightly more difficult problem from your worksheet there. So let's say f of x equals 1/2 x squared minus 2. Let's find the average rate of change from 2 to 4. 2 to 4.
Okay. Uh, oh my god, it's so windy. Okay. Okay. Sorry. Minus 2. Over minus 2. Okay, I got 3 over 2.
That is correct. All right, good. All right. So we're gonna stop for today. I got some real scheduling headaches.